Right now, under the Arctic, there are rivers flowing that have never once touched the air, and lakes that have been cut off from the sun longer than our entire species has existed. And the wildest part? There might be whole ecosystems down there, living things that evolved in total darkness, in total isolation, with no idea the surface even exists. You're standing on top of a sealed world, and with all our satellites and submarines and billion-dollar machines, we still can't get to it. Okay, so if this is the kind of thing that keeps you up at night in the good way, do yourself a favor and hit subscribe. We post this stuff every single week. You can even smash that little bell if you're feeling brave. Cool? Cool. Now let me actually show you what's down there, because it's so much weirder than you think. Let's start with you. Picture this. You're standing on the Arctic ice. It stretches out flat and wide in every direction, all the way to where the sky touches the ground. It feels solid. It feels permanent. It feels like the most lifeless, frozen, nothing place on the entire planet. You could walk for days and see the same blank white emptiness. And your brain tells you, yeah, there's nothing here. Just ice on top of more ice on top of water, all the way down, dead and frozen and silent. And honestly, you would call me crazy if I told you that under your boots, hidden in the dark, there's running water, liquid rivers, actual lakes, maybe even living creatures. You'd call me crazy. Well, you're not alone. For a long time, basically everyone thought the same thing. But unfortunately, you are wrong. And I'm about to explain exactly why. Here's the thing nobody tells you about ice this thick. When you pile up enough of it, kilometers of it, the bottom of that ice sheet isn't doing what you think it's doing. Up at the top where you're standing, it's brutally cold, easily way below freezing. But down at the bottom, two things are happening at once. The first is pressure. All that ice weighs an absolutely insane amount, and that crushing weight squeezes down on the very bottom layer. And pressure basically lowers the melting point of ice. The second thing is heat. Not from above, from below. The Earth itself is warm. The rock under the ice is slowly leaking heat up from the planet's core, a constant trickle of geothermal warmth. So you've got pressure pushing the melting point down, and heat from the Earth pushing up. And right there, at the boundary between ancient ice and solid rock, something happens that feels impossible. The ice melts. Even though it's freezing, even though the surface is one of the coldest places on Earth, the very bottom of the ice sheet turns to liquid water. And that water has nowhere to go. It pools. It collects in dips and basins in the rock far below. And over thousands and thousands of years, it forms lakes. Lakes that have a roof of ice kilometers thick over them. Lakes that have never, not once, seen the sun. And here's the crazy part. These aren't tiny little puddles. Some of these subglacial lakes are massive. Some are bigger than the lakes you can drive to on a weekend. Full-sized bodies of water hidden in pitch-black darkness. And the water doesn't just sit there either. It moves. It flows. There are rivers down there, carving channels through the rock and along the underside of the ice, connecting one hidden lake to another in a network you can't see and can barely even detect from the surface. Now, when I say these lakes have been sealed for a long time, I don't mean a long time the way you mean it when you're waiting for a bus. I mean a length of time that should genuinely break your brain a little. Let me explain. The most famous of all these hidden lakes isn't even in the Arctic. It's down at the other end of the planet, in Antarctica, and it's called Lake Vostok. And Lake Vostok is the example that shows you exactly how mind-bending these places are. Lake Vostok sits under ice that is roughly 4 kilometers thick. 4 kilometers. That's the kind of distance you'd drive without even thinking about it, except now it's straight down, and every meter of it is solid ice. And underneath all of that ice, in total darkness, in total isolation, sits this enormous lake. And the scientists who study it believe it has been sealed off from the outside world for at least 15 million years. Sit with that number for a second. 15 million years. Our species, modern humans, has been around for maybe a couple 100,000 years. So this lake was already sealed, already cut off, already in the dark, for millions and millions of years before the first human being ever drew a breath. Whatever is happening in that water, it's been happening with absolutely no contact with the surface world since long before anything you'd recognize as a person existed. And that raises the question that makes all of this so addictive. If there's water down there, liquid water, and it's been sealed and stable for 15 million years, then is there anything living in it? Because here on the surface, wherever you find liquid water, you basically find life. Life is shockingly stubborn. It shows up in boiling acid pools, in the deepest ocean trenches, frozen into glaciers, baked into deserts. So if there's a giant lake of liquid water that's been sitting there for 15 million years, the obvious, almost unavoidable question is, what's swimming in it? Now here's where you have to throw out almost everything you think you know about how life works. Because everything you've ever learned about the food chain basically starts with the sun. Sunlight hits a plant. The plant does photosynthesis. It turns light into energy and food. Then a bug eats the plant, a bird eats the bug, and so on up the line. Every animal you've ever seen, every meal you've ever eaten, traces back to the sun in the end. That's the rule. That's the foundation. Sunlight powers basically all life on the surface of this planet. But down in Lake Vostok, under 4 kilometers of ice, there has been zero sunlight for 15 million years. Not a single photon. So if there's life down there, it cannot possibly be running on sunlight. The entire foundation of the food chain you grew up with is just gone. So how would anything survive? What would it even eat? And this is where it gets genuinely wild, because we actually know the answer, and we know it because we found this exact trick happening somewhere else first. At the bottom of the ocean, deep down where no sunlight reaches, there are cracks in the seafloor called hydrothermal vents. These are places where superheated water, full of dissolved chemicals and minerals from inside the earth, blasts up out of the rock. And for a long time, scientists figured that the bottom of the ocean must be a dead zone, because no sunlight means no plants, means no food, right? Same logic you were just using. And they were wrong in the most spectacular way. Because clustered around these vents, in the crushing dark, miles below the waves, they found life. Tons of it. Whole thriving communities. And at the bottom of it all were tiny microbes that had figured out a completely different way to eat. Instead of using sunlight, they use chemistry. They pull energy directly out of the chemical reactions happening between the hot water and the rock, and the minerals pouring out of the vents. This is called chemosynthesis, and it basically rewrites the rulebook. Instead of light powering the bottom of the food chain, it's chemistry. It's the raw energy locked inside chemical reactions between water and stone. So now flip back to your hidden lake under the ice. You've got water, you've got rock, you've got minerals. You've got the same kind of slow chemistry between liquid and stone that powers those deep sea vents. Which means life down there wouldn't need the sun at all. It could live entirely on chemosynthesis, sipping energy out of the reactions between the water and the rock it's been sitting on for 15 million years. No light, no plants, no problem. A whole hidden food chain built on chemistry instead of sunshine. And here's the part that turns this from a cool geology fact into something that honestly gives me chills. If life can do that, if it can survive in total darkness, sealed under kilometers of ice, feeding on nothing but the energy of water meeting rock, then suddenly we are not just talking about Earth anymore. We're talking about the rest of the solar system. Because let me tell you about two other places. There's a moon orbiting Jupiter called Europa, and there's a moon orbiting Saturn called Enceladus. And both of these moons have something incredible going on. On the surface, they're frozen solid, sheets of ice, brutally cold, way out in the dark, far from the sun. They look dead. They look like the last places you'd ever go looking for life. But underneath that shell of ice, scientists are now pretty confident there are oceans. Liquid oceans of water, kept warm not by the sun, which is far too distant and weak out there, but by the moon getting flexed and squeezed by the gravity of the giant planet it orbits, generating heat from deep inside. So stop and look at what we've got. An ocean of liquid water, a thick shell of ice sealing it from the surface. Darkness, pressure, heat coming from below instead of from a sun above. Does that sound familiar? Because that is precisely the situation in Lake Vostok and the hidden lakes of the Arctic. Same dark water, same icy roof, same energy from below. The conditions under the ice on our own planet are a near-perfect mirror of the conditions on Europa and Enceladus, hundreds of millions of kilometers away. Which leads to this beautiful, almost poetic realization. When scientists drill into the ice of the Arctic and Antarctica and study what's living in the sealed water beneath, they are not just studying Earth. They are running a rehearsal. A dress rehearsal for the search for alien life. Because if we can figure out how to reach a sealed, dark, icy ocean here, on our home planet, and find living things in it without wrecking the place, then we've basically figured out the playbook for someday doing the same thing on Europa, on Enceladus, on any frozen ocean world out there. The ice under your boots is a practice run for finding aliens. That's not me being dramatic. That's literally the logic driving a huge chunk of this research. But, and this is a massive but, here's where the dream slams face first into reality. Because for all of this to mean anything, we actually have to get down there. We have to reach the water. And it turns out that reaching a lake that's been sealed under kilometers of ice for millions of years is one of the hardest things humans have ever tried to do. It's so hard it almost sounds made up. Let me explain why, because every single part of it is a problem. Let's start with the most basic, most maddening problem of all. It's a paradox so clean it almost sounds like a riddle. We can't map the world under the ice because we can't get to it. And we can't get to it because we don't have a map. Read that again and let it sink in. On the surface, when you want to explore somewhere, you map it first. You send out scouts, you take pictures, you figure out the terrain, and then you plan your route. But under kilometers of solid ice, you can't see anything. You can't send a scout. You can't take a photo. You're blind. So you don't really know where the lakes are, exactly how deep they sit, how big they are, where the rivers connect, where the rock dips and rises. And the only way to truly find out is to drill down and look. But you can't drill blindly everywhere. That's impossibly expensive and slow. So you're stuck. You need the map to explore, and you need to explore to make the map. It's a perfect frustrating loop, and it's why so much of this world is still a total mystery. Now, even when you decide to just go for it and drill, the ice itself fights you every step of the way. And this is the part that genuinely surprised me when I first learned it, so stick with me. You think of ice as a solid, right? Hard, rigid, stays where you put it. You drop an ice cube and it just sits there being an ice cube. But that's only true for small amounts of ice over short amounts of time. When you've got kilometers of ice, under enormous pressure, over long stretches of time, ice stops behaving like a solid. It starts behaving like a thick, slow liquid. It flows. Not fast. Not in a way you'd see by watching it, but relentlessly, the way honey oozes, the way cold tar creeps. The ice sheet is, quietly, constantly, on the move. And that creates absolute nightmares for anyone trying to drill through it. Picture it. You drill a deep, narrow shaft down through the ice. Great, you've got a hole. Except the ice is flowing, so that hole doesn't stay open. The ice slowly squeezes back in and seals the shaft shut behind you, like trying to dig a tunnel through pudding. You drop your drilling equipment down, and the moving ice bends your drill rods, warps them, puts insane stress on them. And here's a detail that just floors me. If you lower a sensor down into the ice and leave it there, The flowing ice can physically carry that sensor sideways, drifting it kilometers away from where you put it over the span of a few years. You don't lose your equipment because it broke. You lose it because the ice slowly walked off with it. The whole landscape you're drilling into is alive and shifting under you, just on a timescale slow enough that it feels solid. So already you've got an impossible map problem, and ice that flows like a liquid and eats your equipment. And we're not done, because the lakes themselves, the very targets you're trying to reach, won't even hold still and wait for you. Here's what I mean. You'd assume that once you find a hidden lake, it's just sitting there, patient, a stable target you can plan an expedition around for years. Nope. These subglacial lakes are connected by those hidden rivers and channels I mentioned, and sometimes, without warning, they drain. And not gently. A lake can suddenly dump billions of liters of water out of itself in a matter of days, the water rushing off through the channels under the ice, carving brand new paths through the rock and ice as it goes. Billions of liters, gone in days. Which means you can spend years studying a lake from the surface, planning the perfect expedition, getting your funding, building your equipment, organizing your team, and the lake you've been aiming at could literally drain away and vanish before your drill ever reaches it. Your target just disappears. The water you crossed the planet to study has flowed off somewhere else entirely. It's like planning an expedition to a destination that might pack up and leave while you're on the way. And then, even if you solve all of that, even if you've got your map sorted, even if you've fought through the flowing ice, even if your target lake stays put long enough for you to reach it, there is one more problem. And this one isn't about getting in. It's about not destroying the very thing you came to find. This is the problem that haunts every single scientist working on this, and it is brutal. Think about what these lakes are. They've been sealed and pristine for hundreds of thousands, even millions of years. If there's an ecosystem down there, it evolved in perfect isolation, completely untouched by the outside world, by us, by any of the bacteria and microbes that cover absolutely everything on the surface. And now picture you drilling down through kilometers of ice with a giant machine, a machine that came from the surface, a machine covered in the regular, ordinary, modern microbes that live on basically every object on Earth. The moment your drill punches through into that sealed water, you have a contamination problem of historic proportions. Because here's the gut punch. A single modern bacterium from your drill, just one, dropping into a lake that's been isolated for hundreds of thousands of years, could wipe out the entire ancient ecosystem before you even get a chance to study it. The life forms down there have spent an unimaginable span of time evolving in a closed bubble. They've never met our surface microbes. They might have no defenses against them at all. So you could march in there hoping to discover an ecosystem that's been hidden since before humans existed, and in the very act of looking, accidentally murder it with a stray germ of your equipment. You could destroy the discovery of the century by the simple act of trying to make it. That is the razor's edge every one of these expeditions walks. Get in, but stay clean enough that you don't poison a world that's been pure for millions of years. Now here's where you might be thinking, okay, this all sounds amazing, but it also sounds like pure theory. Cool ideas, sealed lakes, alien rehearsal vibes, but has anyone actually done it? Has anyone actually drilled down and found out what's really there? And the answer, the thing that takes this whole story from a fun what if into something genuinely real, is yes, they have. And what they found changes everything. Let's go back to Lake Vostok first, because that's the big famous one, and its story is honestly a perfect example of how hard all of this is. The Russian team that set out to drill into Lake Vostok didn't knock it out in a season or two. They spent decades on it. Decades. Imagine pouring years and years of your career, of your team's lives, of funding and equipment and brutal Antarctic field seasons, all into drilling one hole through 4 kilometers of flowing, fighting ice. They started the long process, dealt with every problem I've described, the pressure, the flowing ice, the contamination fears, all of it. And they kept going year after year after year. And finally, In 2012, after all those decades of effort, they made it. They reached the water of Lake Vostok, a lake sealed for 15 million years, and human beings finally touched it. And here's the deflating, very human part. After all that, the samples they got were inconclusive. Not a clean, triumphant discovery. Not a clear yes or no on whether life thrives down there. Just murky, uncertain results, complicated by exactly the contamination worries we talked about, by the difficulty of being sure that whatever they found came from the lake and not from the drilling itself. Decades of work, 4 kilometers of ice, 15 million years of mystery, and the answer came back as a frustrating maybe, which tells you everything about how hard this really is. Even when you win, when you actually reach the impossible target, the ice and the contamination and the sheer difficulty can rob you of a clean answer. But don't let that ending fool you into thinking it's all that ends. Because there's another expedition, another lake, and this one delivered. This is the one that proves the dream is real. In 2013, a team drilled down through the ice of Antarctica into a different hidden lake, a subglacial lake called Lake Wilance. And unlike the murky results from Vostok, what they pulled up from Lake Wilance was crystal clear and absolutely stunning. They found life, living microbes. Down there in the sealed dark, cut off from the sun, they found microorganisms that were alive and thriving. And remember everything we said about how life would have to work down there, with no sunlight, no photosynthesis, running entirely on chemistry instead? Well, that's exactly what these microbes were doing. They were feeding on iron, on sulfur, on nitrogen, pulling their energy out of chemical reactions with the minerals around them. Exactly the chemosynthesis playbook from the deep sea vents. A complete functioning ecosystem, alive, working, sealed away from the sun, running on the energy of chemistry. Not a theory, not a maybe. An actual, confirmed, living world under the ice, discovered by drilling down and looking. Microbes eating iron and sulfur and nitrogen in a lake that the sun has never touched. And that, right there, is the proof that everything we've been talking about isn't just a daydream. The hidden lakes are real. The liquid water is real. Life without sunlight, running on chemistry in total darkness, is real. Because we reached down and found it living. Which means the bigger dream, the idea that the same thing could be happening under the ice of Europa and Enceladus, suddenly isn't science fiction at all. It's the most reasonable guess in the world. If life can do this here, in the dark under our own eyes, why on Earth, or why anywhere, would it not be doing the same out there? Now let's zoom back out and really picture the scale of what's hidden, because once you understand the pieces, the full image of it is staggering. You started this with a simple mental image, the Arctic as a flat, frozen, lifeless desert, just blankness in every direction. And now you know that picture is hiding an entire concealed planet's worth of geography. Under that ice there are basins and valleys and ridges in the rock, all carved and shaped over millions of years. There are lakes feeding those basins, some small, some enormous, all of them in pitch darkness. There are rivers connecting them, flowing water threading through channels you'd never see from above, sometimes gone for centuries, sometimes suddenly surging with billions of liters draining from one lake to the next. It's a landscape. A real, full landscape, with terrain and water systems and movement. And it's all hidden under a roof of ice, completely invisible from the surface where you stand thinking it's just empty white nothing. And it's not static. That's the part that really gets me. This is not a frozen, paused world waiting patiently for us. It's a living, shifting system, just running on a clock so slow that to us it looks frozen. The ice flows like syrup. The lakes fill and drain. The rivers carve new paths. There's chemistry happening between water and rock, and where there's chemistry, there might be life feeding off it. All of this, the flowing and draining and feeding and living, is happening right now, under your feet, in the dark, and you can't see a single bit of it. The most active hidden world you could imagine, disguised as the most lifeless landscape on the planet. And let's go back to that paradox one more time, because the more you think about it, the more beautiful and maddening it gets. We can't map the underwater world because we can't reach it, and we can't reach it because we don't have a map. That single sentence captures the whole frustration of this field. We've put rovers on Mars. We've flown probes past the outer planets. We've sent spacecraft beyond the edge of the solar system. And yet, a few kilometers straight down, under the ice on our own planet, there's a world we still can't properly explore. We know more about the surface of distant moons than we do about the lakes hidden right under our own ice. The frontier isn't always far away in space. Sometimes the most unreachable place is directly below you. And think about the obstacles all stacked together, because each one alone would be a huge problem, and they all hit at once. Problem 1. You're blind, no map, no way to see what you're aiming at. Problem 2. The ice flows like a liquid, sealing your shafts, bending your rods, walking off with your sensors over the years. Problem 3. Your target lake might just drain away and vanish before you even arrive. Billions of liters gone in days. And problem 4, the worst one. Even if you reach it, one stray modern germ of your drill could wipe out the ancient ecosystem you came to study before you ever get to understand it. Any single one of those would make this hard. All four together make it one of the toughest exploration challenges humans have ever faced. And yet people keep doing it, keep drilling, keep trying, because of what's waiting at the bottom. And what's waiting is the answer to a question that's bigger than the Arctic, bigger than Antarctica, bigger than Earth. Because every time a team reaches one of these lakes and finds living microbes eating iron and sulfur in the dark, they're proving something profound. They're proving that life doesn't need the sun. They're proving that life can take hold in places we'd written off as impossible, in sealed darkness, under crushing ice, running on nothing but the slow chemistry of water against rock. And the second you accept that, the universe stops looking so empty. Every frozen moon out there with a hidden ocean stops being a dead rock and starts being a maybe. And maybe there's something alive down there too. And maybe we're not alone. Which just goes to show that the most important discoveries aren't always in the places you'd expect. You'd expect aliens to be found by a telescope pointed at the stars, by some signal from light years away. But it might turn out that the first real clues come from a drill grinding down through ice on our own planet, from a tiny iron-eating microbe in a lake that's been dark for millions of years. Studying the bottom of our own ice sheets is, in a very real way, the first step in learning how to find life on other worlds. Now let's really sit inside what it would be like to be one of the people doing this, because I think it makes the whole thing land harder. Picture this. You're on the ice. Wind that cuts straight through everything you're wearing. A landscape so flat and white and empty it plays tricks on your eyes. No landmarks, no edges, just blank in every direction. And you and your team have hauled an entire drilling operation out to this nothing place. Machines and fuel and hot water drills and sensors and clean equipment. Because somewhere directly below you, kilometers down, there's a lake. You can't see it. You can't be totally sure of its exact shape, or whether it's still there. You're trusting your instruments and your maps, which barely exist, and you're about to spend an enormous chunk of your life punching a hole down toward a thing you've never seen and might not even reach. And as your drill bites down through the ice, you're fighting the clock and the cold and the flowing ice all at once. You've got to keep the shaft from searing. You've got to keep your equipment from bending or drifting. You've got to keep everything obsessively clean, because you know that the moment you break through, one careless germ could ruin everything, could murder the very ecosystem you're risking everything to find. The pressure of that is enormous. You're not just trying to succeed, you're trying to succeed without destroying the prize in the process. And then, finally, after weeks or months, or in some cases years and even decades, The drill breaks through into liquid water. Water that hasn't felt anything from the surface world in hundreds of thousands, maybe millions of years. And you pull up a sample, and you look at it. And in that tiny precious bit of dark water, you find life. Microbes, alive, eating iron and sulfur. A whole ecosystem that has been running silently in the dark since before your species existed. That actually happened. That's the Lake Wilance story. That's real. Somebody actually stood on that ice, drilled into that buried, sealed world, and found it wasn't dead at all. It was alive. And every detail of how hard that was, the blindness, the flowing ice, the draining lakes, the contamination terror, all of it had to be overcome to get that single answer. Yes, there's life down there. And here's the thing I keep coming back to. We've barely scratched the surface, literally. Lake Vostok gave us a frustrating maybe after decades of drilling. Lake Wilance gave us a thrilling yes. But there are many more of these hidden lakes, all across Antarctica and under the Arctic. Most of them never touched, never sampled, never seen. A whole catalog of sealed, dark worlds, each one possibly holding its own ancient ecosystem, its own life that's never met the surface, its own answers about what life can do and where it can survive. And we've reached, what, a tiny handful of them? The vast majority are still down there, still sealed, still waiting, still hidden under ice that flows like syrup and fights us every step of the way. So the next time you see a photo of the Arctic, that endless flat white expanse that looks like the deadest, emptiest place imaginable, I want you to remember what's actually under there. Not nothing, not emptiness. A hidden world of rivers that have never touched the air. Lakes sealed in darkness since before humans existed. Water flowing and draining and carving in the black. And maybe, in the cold and the dark and the crushing pressure, things that are alive, feeding on chemistry, living their entire existence with no idea the sun even exists. A whole planet's worth of mystery, hiding right at the top of our own. And the truly humbling part is that this is one of the last great unexplored frontiers we have. And it's not on Mars. It's not on some distant moon. It's right here, under our feet, at the top of the world. We have the technology to send machines across the solar system, and yet this sealed world a few kilometers below the ice still mostly defeats us. The ice flows and reseals our shafts. The lakes drain and vanish. The contamination problem keeps us terrified of our own equipment. And the paradox loops on forever. No map without exploration. No exploration without a map. It's the perfect locked door. And behind it might be one of the most important answers humans have ever chased. Because if life is down there, thriving in total isolation, running on nothing but the energy of water meeting stone, then we've learned something staggering about how stubborn and creative life really is. And we've learned the playbook for finding it elsewhere. Every iron-eating microbe pulled from a lake under the Antarctic ice is, in a way, a tiny ambassador, a proof of concept, a sign that says the universe might be a lot less empty than it looks, that the frozen moons of Jupiter and Saturn, with their dark hidden oceans under shells of ice, might be hiding the same kind of secret life that we're only just beginning to find under our own ice right here at home. So yeah, there's a hidden world under the Arctic, and under Antarctica too, sealed in the dark, flowing and draining and carving in silence, maybe teeming with ancient life that runs on chemistry instead of sunlight. We've reached down and touched the edge of it. We've found that it's alive. And the wildest part is that, with all our technology, for all our reaching toward distant planets, this buried world right beneath us is still mostly out of our grasp, still keeping its secrets, still waiting at the very top of the planet for someone clever enough, careful enough, and patient enough to finally read the whole story written in the dark. So we've established the big picture. There's a hidden world under the ice, full of dark lakes and rivers. and we've actually reached into a couple of them and found life. But now I want to take you deeper into the how of all this, because the more you understand about the way the spirit world actually works, the more insane it gets. And the first thing we need to talk about is the ice itself, because honestly, the ice is the real villain of this whole story, and you don't really get it until you understand how strange it is. Okay, so think about ice the way you normally do. An ice cube in your drink, a frozen pond you could skate on, a patch of ice on the sidewalk that makes you eat it on your way to work. In all those cases, ice is hard, brittle, rigid. You hit it, it cracks. It stays exactly where it is. It does not, under any circumstances, ooze around like a liquid. That's just not a thing ice does, right? In your everyday life, ice is the definition of solid and still. But here's the thing. That's only true at small scales and short times. The second you start stacking up kilometers of ice, and the second you start measuring time in centuries and millennia instead of minutes, ice turns into a completely different beast. Under the weight of all that ice piled on top of it, and over those enormous stretches of time, ice begins to flow. Not crack, not shatter. Flow. It creeps and oozes like an unbelievably thick, slow liquid. Picture cold honey poured onto a table, spreading out under its own weight, except slowed down so much that you'd have to watch for years to see it move at all. That's what an ice sheet is doing, constantly, right now. It is, quietly, a river. Just a river running so slowly your eyes can't catch it. And once you wrap your head around that, all of the drilling nightmares I mentioned before suddenly make perfect, terrible sense. Let me walk you through what it's actually like, because it's genuinely one of the most frustrating engineering problems you could ever sign up for. You decide you're going to drill down to a hidden lake. So you fire up your equipment and you bore a narrow shaft straight down through the ice. Beautiful. You've got your hole. You can fit your equipment down it. Job's going great. Except the ice is flowing. So that hole you just made? It does not want to stay a hole. The surrounding ice is slowly, relentlessly squeezing inward, pressing back into the empty space you created, trying to seal the shaft shut behind you. It's like digging a tunnel through wet clay or thick pudding, where the walls keep slumping back in the moment you stop digging. So now you're not just fighting to get down, you're fighting to keep your path open at all, because the ice is actively trying to close the door behind you the entire time. And it gets worse, because that flowing ice doesn't just close your shaft, it pushes on everything you put inside it. You lower long, rigid drill rods down into that hole, and the ice, moving at different speeds at different depths, grabs at those rods and bends them. It warps them. It puts incredible sideways stress on equipment that was designed to go straight down, not to get shoved sideways by a moving wall of ice. Your gear is constantly being twisted and strained by a force you can't see and can't stop. And then there's the detail that, when I first heard it, genuinely made me put my hands on my head. If you lower a sensor down into the ice and leave it there to take measurements over time, the flowing ice can physically carry that sensor away, not break it, not crush it. Just slowly walk off with it. Over a span of years, the moving ice can drag a sensor kilometers from where you originally placed it. Think about that. You carefully position a delicate instrument at a precise spot, and the landscape itself, the ice, slowly transports it a couple kilometers sideways like a glacier speed conveyor belt. You didn't lose it to a malfunction. You lost it because the ground it was sitting in is alive and on the move, just on a timescale that makes it look frozen to us. That is the thing you have to keep reminding yourself. Everything that looks frozen and dead and still up there is actually moving. The whole landscape is in motion. It's just running on a clock so slow that, to a human standing on it for a few weeks, it looks like the most permanent, motionless place on Earth. And that mismatch between how still it looks and how much it's actually moving is exactly what makes it so hard to work with. Now let me explain why this flowing ice creates a problem that's even sneakier than just bending your equipment. Remember the paradox? We can't map this world because we can't reach it, and we can't reach it because we don't have a map. Well, The flowing ice makes that paradox even worse, and here's how. Even if you do manage to figure out roughly where a lake is, the ice on top of it is moving. So the surface point you'd drill from isn't fixed relative to the lake below. The ice flows over the lake, sliding across the top of it, which means the spot on the surface that's directly above the lake today might not be directly above it in the same way over long timescales. You're trying to aim a drill at a target through a medium that is itself sliding around. It's like trying to drop a coin through a moving escalator into a specific cup at the bottom, except you can't see the escalator or the cup, and both might be moving. And here's the crazy part about why the lakes even exist in this moving flowing system. You'd think a flowing ice sheet would just smear everything out, that any water would get squeezed away or dragged off. But the geography of the rock underneath creates basins, low spots, dips and bowls in the bedrock. And water, being water, collects in those low spots. So even with the ice sliding over the top, the meltwater at the very bottom pulls into the basins in the rock and forms these stable lakes. The ice roof flows over them. The lake sits in its rocky cradle below, and you get this strange situation where the lid is moving but the lake stays put, held in place by the shape of the land beneath it. It's a delicate, weird balance, and it's been holding for millions of years in places like Vostok. Now, speaking of the water, let's talk about how that water actually behaves, because it's not just sitting there being a calm, still pond either. I told you these lakes connect through hidden rivers and channels, and that sometimes they drain suddenly. But let me really put you inside what that means, because it's wild. Imagine a network of lakes under the ice, linked by channels the way a chain of mountain lakes might be linked by streams, except all of it is buried in pitch darkness under kilometers of ice. For long stretches, everything's calm. The lakes hold their water. The channels are quiet. Centuries pass. The system looks stable. And then, without any warning you could detect from the surface, something shifts. A seal gives way. A channel opens up. And one of these lakes just lets go. Billions of liters of water start rushing out of it, surging through the channels under the ice, draining away in a matter of days. Billions of liters. Gone. In days. And as that water rushes through, it carves. It cuts new channels through the rock and along the underside of the ice, reshaping the hidden plumbing of this whole world as it goes. The map of where the water is and where it flows can literally rewrite itself in the span of a week. All of it invisible, all of it happening under that flat white surface that, from above, doesn't change at all. And this is where it becomes a genuine, practical nightmare for the people trying to study these lakes. Let me explain why this is so brutal. Reaching one of these lakes isn't something you do on a whim. It takes years of preparation. You have to find the lake in the first place, which is hard because, remember, you're basically blind. Then you have to plan an entire expedition to one of the most hostile environments on the planet. You need funding, which can take years to secure. You need to design and build specialized equipment that can survive the cold and the pressure and the flowing ice. You need a team, logistics, fuel, supplies, transport across some of the most remote terrain on Earth. By the time you're actually standing on the ice with your drill ready, you might have spent the better part of a decade getting there. And here's the gut punch. The lake you've spent all those years planning to reach might not be there anymore. It could have drained. While you were busy securing funding and building equipment and organizing your expedition, the lake could have quietly let go of its billions of liters and emptied out through the channels, leaving you to drill down to a target that has simply vanished. You crossed the planet, you spent years and a fortune, and the thing you came for packed up and left. It's like planning a trip for 10 years to visit a specific island and arriving to find the island just isn't there anymore. That's the kind of instability we're dealing with. The targets themselves won't hold still. Now you might be wondering, okay, if everything is so hidden and so hard to reach, how do scientists even know these lakes are there at all? How do you find a lake you can't see, can't reach, and can't reliably map? And this is actually a really clever part of the story, so let me explain how they pull it off, because it's a great example of human ingenuity working around a seemingly impossible problem. They can't see through the ice directly, but they can do a few sneaky things from the surface and the air. One trick involves looking at the surface of the ice very, very carefully. Because here's the thing. When there's a big lake of liquid water underneath the ice, that lake affects the ice above it. Liquid water is slippery and flat compared to rock, so the ice sliding over a hidden lake behaves differently than ice grinding over solid bedrock. Sometimes the surface of the ice above a buried lake is unusually flat and smooth, because the lake below acts like a slippery, level floor that the ice can slide over evenly. So from above, even from a satellite, you can spot these strangely flat patches and go, there might be a lake under that. The lake leaves a faint fingerprint on the surface, kilometers above it, if you know how to read it. Another trick is watching how the surface of the ice rises and falls over time. Remember, when a hidden lake fills up or drains, it's moving billions of liters of water around down there. And when that water moves, the ice on top of it can actually suck or bulge in response. If a lake drains, the ice above it can slowly sink as the water that was holding it up disappears. If a lake fills, the ice can rise. So by carefully measuring tiny changes in the height of the ice surface over months and years, scientists can detect the breathing of these hidden lakes, the slow rise and fall as water moves through the buried system. The surface is basically a faint, blurry readout of the secret plumbing far below. And then there's a big one, which is sending signals down through the ice itself. You can fly aircraft over the ice and beam certain kinds of waves down into it. These waves travel down through the ice, and when they hit a boundary, like the line between ice and rock, or the line between ice and liquid water, they bounce back. And the way they bounce back is different depending on what they hit. Liquid water reflects these signals in a distinctive way, very differently from solid rock. So by sending signals down and listening to the echoes that come back, scientists can build a rough picture of what's down there, where the ice ends, where the rock is, and where there might be liquid water pulled in between. It's a bit like tapping on a wall to figure out where the hollow spaces are, except the wall is kilometers of ice, and the tapping is done with carefully chosen waves from an aircraft flying overhead. But here's the catch, and it brings us right back to the paradox. All of these methods, the flat surface fingerprints, the rising and falling ice, the bouncing signals, they only give you a blurry, indirect, rough picture. They tell you there's probably a lake roughly over there, roughly that big, roughly that deep. They cannot tell you what the water is actually like. They cannot tell you if anything is living in it. They cannot give you the clean, detailed map you'd really want before committing a decade of your life to drilling down. For that, for the real answers, there is no shortcut. You have to physically drill down and look. The remote sensing gets you a fuzzy treasure map with a big rough X on it. But to find out if there's actually treasure, you have to dig. And digging, as we've established, is where all the nightmares live. So let's go back down into the lake and talk about the most exciting question of all, the one that makes all this effort worth it. What is actually living down there, and how on earth does it survive? Because I want to really drive home just how alien this kind of life is compared to everything you know. Every living thing you have ever seen, every plant, every animal, every bug, every fish, every person, sits on top of a food chain that begins with the sun. I said this before, but it's worth saying again, because it's the foundation we have to demolish. Sunlight hits a green plant or some algae, and through photosynthesis, that organism captures the light's energy and turns it into food, into sugars, into living tissue. Then something eats the plant, then something eats that thing, and on up the chain, until you get to the big stuff at the top. Trace any meal you've ever eaten back far enough, and you always end up at the sun. The entire web of life on the surface of this planet is, fundamentally, solar-powered. The sun is the engine. Take away the sun, and the whole familiar food chain collapses, because there's nothing at the bottom of it anymore. Now drop yourself into one of these subglacial lakes. Vostok, sealed under 4 kilometers of ice for 15 million years. There has not been a single ray of sunlight down there for longer than our species has existed. Photosynthesis is completely off the table. There are no plants. There can be no plants, because there's nothing for a plant to do its job with. The engine that powers all the life you know, the sun, simply does not reach this place and hasn't for an unimaginably long time. So by the logic you grew up with, this place should be utterly, completely dead. Empty, sterile. And yet we drilled into Lake Williams in 2013 and found it teeming with living microbes. So how? How is anything alive in a place the sun forgot millions of years ago? And the answer, as we touched on, is chemosynthesis. But let me really explain what that means. Because it's one of the most beautiful tricks in all of biology. And it completely changes how you should think about where life is possible. Instead of using the energy of sunlight, these microbes use the energy locked inside chemical reactions. Down in the lake, you've got water and you've got rock. And that rock is full of minerals, iron, sulfur, all sorts of elements. And when water and certain minerals interact, when chemicals meet and react, energy is released. It's the same fundamental idea as a battery. Energy stored in chemistry, waiting to be tapped. And these microbes have evolved to do exactly that. They feed on iron, they feed on sulfur, they feed on nitrogen. They pull the energy out of the chemical reactions happening between the water and the minerals around them, and they use that energy to live and grow and reproduce. No sunlight required. The sun is completely irrelevant to them. Their entire world runs on chemistry, on the slow, patient reactions between water and stone. And here's the thing that makes this so profound. This isn't some fragile, barely hanging on, half-alive situation. What they found at Lake Williams was a functioning ecosystem, a working web of life, with microbes living off the chemistry, sealed away from the sun, humming along just fine in the dark. It's not life clinging on by its fingernails. It's life that found a completely different power source and built a whole thriving community around it. Life, it turns out, is way more flexible and stubborn and creative than the sun-powered version you grew up assuming was the only way. And we know this trick isn't a fluke, because we'd seen it before, down at the bottom of the ocean. Let me take you there for a second, because it's the discovery that taught us to even imagine life like this. Deep, deep down in the ocean, far below where any sunlight can reach, there are spots on the seafloor where the Earth's internal heat leaks out. Cracks where superheated water, loaded with dissolved minerals from inside the planet, comes blasting up out of the rock. These are the hydrothermal vents, and for the longest time, scientists assumed the deep seafloor must be a barren desert, because again, no sunlight, no plants, no food, no life. Same assumption you'd make. And then they actually went down and looked, and what they found around these vents shattered everything. Not a desert, an oasis. Thriving communities of life clustered in the crushing dark, miles below the surface. And at the base of it all were microbes doing chemosynthesis, feeding on the chemicals pouring out of the vents, building a food chain that had nothing to do with the sun at all. Life, thriving, in one of the most extreme, sunless, high-pressure environments imaginable, running entirely on the Earth's internal chemistry. That discovery rewrote the rulebook. It told us that wherever you've got liquid water, an energy source, and the right chemicals, life can take hold, even with the sun completely out of the picture. And now you can see the connection clicking into place. The deep-sea vents and the subglacial lakes are running on the same fundamental principle. Liquid water, check. Rock and minerals to react with, check. An energy source from chemistry rather than sunlight, check. Darkness, check. So if life figured out how to thrive around the vents, then it's not a stretch at all to expect it could thrive in a sunless lake under the ice too. And sure enough, when we drilled in, there it was. The same trick, in a different sealed darkness. Life feeding on iron and sulfur and nitrogen, far from the sun, exactly as the deep-sea vents had taught us to expect. And here is where this whole story stops being just about Earth and explodes into something cosmic. Because the moment you accept that life can run on chemistry in a dark, sealed, watery environment with no sun, you have to start looking up. Specifically, you have to start looking at two particular moons out in our own solar system, because they are dead ringers for the conditions we just described. The first is Europa, one of the moons of Jupiter. From the outside, Europa looks like a frozen, cracked billiard ball. A shell of ice covering the whole moon, way out by Jupiter, far from the sun, brutally cold. By every surface appearance, it's a dead, frozen rock. But scientists are now fairly confident that underneath that shell of ice, there's an ocean. A real, liquid water ocean, sloshing around in the dark beneath the frozen crust. And the reason that ocean stays liquid so far from the sun isn't sunlight, obviously. It's that Europa gets squeezed and flexed by the immense gravity of Jupiter as it orbits. That constant flexing generates heat deep inside the moon, and that internal heat keeps the ocean from freezing solid. Heat from below, not light from above. Now, does that setup sound familiar? An ocean of liquid water. A thick roof of ice sealing it off from the surface. Total darkness. Heat coming from inside rather than from a distant sun. That is, almost exactly, the recipe for our subglacial lakes here on Earth. Europa is basically a giant, moon-sized version of Lake Vostok. Same dark water, same icy lid, same internal energy source. And then there's Enceladus, one of the moons of Saturn. Same general story. A frozen surface, way out in the cold dark of the outer solar system, with strong evidence of a liquid water ocean hidden beneath the ice. And Enceladus does something even more tantalizing. It actually sprays plumes of water out into space through cracks in its icy shell, like geysers blasting from the south of the moon, which tells us pretty clearly that there's liquid water down there, and that it's interacting with rock, because those plumes carry chemical hints of exactly that kind of water-rock activity. Liquid ocean, icy roof, darkness, heat from within, and chemistry between water and stone. Check, 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 and check. So now stack it all up. Here on Earth, we have sealed, dark, sunless lakes under the ice. We drilled into one, and we found a thriving ecosystem running on chemistry instead of sunlight. Out in the solar system, we have moons with sealed, dark, sunless oceans under the ice, kept liquid by internal heat, with chemistry happening between their water and their rock. The conditions match. They genuinely match. Which means the life we found under our own ice is the strongest possible hint that the same thing could be happening on Europa, on Enceladus, in oceans hundreds of millions of kilometers away. And this is the realization that I find absolutely staggering. So let me spell it out. When scientists drill into the ice of Antarctica or the Arctic and study the sealed water and the life within it, they are not just doing Earth science. They are rehearsing. They are doing a full dress rehearsal for the search for life beyond Earth. Every problem they solve here, how to drill through kilometers of ice without contaminating what's below, how to detect and study microbes in sealed water, how to reach a dark ocean under a frozen shell without wrecking it. Every single one of those is a problem we'd have to solve to go searching for life on Europa or Enceladus. The ice under your feet on this planet is the practice arena for finding aliens on another world. We are learning the moves here, on home turf, before we ever attempt the real thing out there in the dark. And that reframes everything. Suddenly a microbe in a lake under the Antarctic ice isn't just a curiosity. It's a proof of concept for the entire idea that the universe might be full of life hiding under ice, in dark oceans, on frozen moons we used to write off as dead. Every iron-eating bug we pull from the dark down here is whispering that maybe, just maybe, those frozen moons aren't dead at all. Maybe they're hiding the same kind of secret we're only now learning to find at home. Which brings us right back to the contamination problem, because it takes on a whole new weight when you frame it this way. Remember, the great terror of every one of these expeditions is that a single modern microbe from our equipment could wipe out an ancient sealed ecosystem before we even get to study it. And now think about that in the context of someday drilling into Europa or Enceladus. If we ever sent a probe to melt down through the ice of one of those moons and into their hidden oceans, we'd be facing the exact same nightmare, except even higher stakes. Imagine traveling all the way to another world, finally reaching its hidden ocean, and then accidentally seeding it with Earth bacteria, destroying or corrupting whatever native life might be there before we could even confirm it existed. That would be one of the greatest tragedies in the history of exploration. So learning right now here on Earth how to drill into a sealed world without contaminating it isn't just good science etiquette. It's a rehearsal for the moment we might do the same thing on a moon, where getting it wrong would be unforgivable. That's why those teams are so obsessive about keeping their equipment clean. That's why a stray germ of a drill bit is treated as a genuine catastrophe. They're not just protecting one lake. They're practicing the discipline we'd need to responsibly search for life anywhere there's ice and a hidden ocean. They are learning how to look without breaking what they are looking at, and that skill might one day be the difference between discovering alien life and accidentally destroying it. Now let me bring you back down to Earth, literally, and put you back on the ice, because I think the human reality of this is worth feeling. Picture this. You're part of one of these expeditions. You've been planning this for years. You and your team have hauled an enormous operation out onto the ice, in one of the most hostile remote places on the entire planet. The cold is unlike anything in normal life. The landscape is so flat and featureless and wide that it messes with your sense of distance and direction. There are no trees, no hills you can name, no landmarks, just an endless blank expanse with the wind screaming across it. And somewhere directly below you, kilometers straight down, is the lake you've devoted years of your life to reaching. You can't see it. You can't be totally sure it's still there. You're trusting fuzzy maps built from bouncing signals and surface measurements and a lot of educated guesswork. And you start to drill. And immediately, the ice begins its quiet war against you. The shaft wants to close. The ice presses in. You're managing the flow, keeping the hole open, watching for the bending and the strain on your equipment. The cold is fighting your machines. The pressure deep down is enormous. And running through all of it, like a constant low hum of dread, is the contamination problem. Because you know that all of this effort, all of these years, could be undone in an instant if you let your equipment carry a single careless germ down into that pristine water. So you keep everything clean to a degree that borders on paranoid, treating every surface, every tool, every drop of fluid as a potential weapon that could murder the very thing you came to discover. And you keep going. For weeks, for months. Maybe, like the Vostok team, you'd be part of an effort that stretches across decades, generations of researchers passing the work along, all chasing the same buried lake. And then, finally, the drill breaks through. Liquid water. Water that has not had any contact with the surface world in hundreds of thousands, maybe millions of years. You pull up a sample, this precious little bit of water from a world that's been sealed since before humans existed. And you look at it. And there, in that dark water, you find life. Microbes, alive, feeding on iron and sulfur and nitrogen. An entire ecosystem that has been quietly running in the pitch black for longer than your species has walked the earth. That's not a fantasy. That's the Lake Wilance reality from 2013. Somebody actually did that. They actually drilled down into a sealed, dark, buried lake and found that it wasn't dead at all. It was alive. And every brutal obstacle, the blindness, the flowing ice, the draining lakes, the contamination terror, every single one of them had to be beaten to get to that one beautiful answer. There is life under the ice. And that answer didn't just tell us something about Antarctica. It told us something about the whole universe, about every frozen moon with a hidden ocean, about how stubborn and creative and unkillable life really is. And that's the thing I keep circling back to, because it just goes to show how wrong our first instinct was. You started out picturing the Arctic as the deadest, emptiest, most lifeless place imaginable. A frozen wasteland with nothing in it. And the truth turned out to be almost the exact opposite. Beneath that frozen blankness is a hidden, moving, living world. Ice that flows like syrup, lakes that fill and drain and breathe, rivers carving new paths in the dark, and life, real life, feeding on chemistry in a place the sun forgot millions of years ago. The emptiest looking place on Earth is hiding one of its most active and mysterious secrets, and we've only just barely begun to reach it. Now I want to back up and really sit with that paradox again, because it's the thing that defines this entire field, and the more you turn it over in your head, the more it does your head in. We can't map the world under the ice because we can't get to it, and we can't get to it because we don't have a map. That's the trap. That's the locked door. And it's worth understanding exactly why it's so impossible to escape. Because it's not just a cute riddle, it's the genuine reason that a world a few kilometers below us is, in some ways, less explored than the surface of Mars. Think about how exploration normally works on the surface of the Earth. When humans wanted to explore a continent, they could walk into it. They could see the rivers, follow the coastlines, climb the hills, look at the mountains, and slowly piece together a picture. When we wanted to explore the ocean floor, it was harder, but we could still send down sound waves, drag instruments, eventually send submarines and cameras to actually look. Even when we explore other planets, we send orbiters that photograph the whole surface from above, building detailed maps before we ever land anything. In every case, you get to look first. You build the map, then you explore. Then you refine the map, then you explore more. See, map, repeat. That's how it's always worked. But the world under the ice breaks that whole cycle. You cannot look. The ice is kilometers thick and you can't see through it. The best you can do, as we talked about, is bounce signals down and read faint fingerprints on the surface. And that gives you a blurry, smeared, uncertain picture. A rough idea that there's probably a lake roughly over there. It does not give you a real map. And to get a real map, to actually know what's down there, you have to physically go to each spot and drill, which is so expensive and slow and brutal that you can only do it in a tiny handful of carefully chosen places. So you can't afford to drill everywhere to make a map, and you can't make a good map without drilling. The two needs strangle each other. You need the map to know where to drill, and you need to drill to make the map. And so most of this buried world stays unknown, locked behind a door that needs the key that's on the other side of the door. And here's what really gets me about that. We have, in a very real sense, better maps of distant worlds than we do of the ground beneath our own feet. We've mapped the surface of Mars in incredible detail. We've photographed the moons of Jupiter and Saturn. We've charted the far side of our own moon. And yet, a few kilometers straight down through the ice on our own planet, there's a landscape of lakes and rivers and basins that we can barely sketch in rough outline. The frontier we think of as the ultimate unknown is space, out there, far away. But one of the genuinely last great unexplored frontiers is right here, directly below us, hidden under the ice. Not far away at all, just sealed off so completely that distance has nothing to do with it. And let me explain why that's such a strange thing to wrap your mind around. Distance normally is the thing that makes exploration hard. The reason we haven't been to other star systems is that they're unfathomably far away. The reason it took so long to map the ocean floor is that it was hard to reach, deep and dark and far below. But the world under the Arctic and Antarctic ice isn't far at all. In terms of pure distance, it's right there. You could, in theory, point straight down and say, it's just a few kilometers that way. But those few kilometers are kilometers of flowing, crushing, self-healing ice. And that makes them harder to cross than enormous distances across open space in some ways. It's not the distance that defeats us, it's the medium. It's the ice itself, fighting us the entire way. So let's really dig into that, because I think people underestimate just how many separate, independent problems stack up here. This isn't one hard thing. It's a whole tower of hard things, each one of which would be a serious challenge on its own, and they all hit you at once. Let me count them out so you can really feel the weight of it. Problem 1. You're blind. You don't have a real map. You're aiming at targets you can't see, using fuzzy guesses from bouncing signals and surface fingerprints. So before you even start, you're working with bad information about where to go. Problem 2. The ice flows like a thick liquid. It seals your shafts behind you, squeezing the hole shut. It bends and warps your equipment with sideways pressure. It can physically carry your sensors kilometers away over a span of years. The very medium you're drilling through is alive and on the move, just slowly enough to look frozen. Problem 3. The targets won't hold still. The lakes are connected by hidden rivers, and they can drain suddenly, dumping billions of liters of water in a matter of days, carving new channels and reshaping the whole hidden system. So the lake you spent a decade planning to reach might simply not be there when you arrive. Your destination can vanish. And problem 4, the worst one. The one that keeps the scientists up at night. Contamination. These lakes have been sealed and pristine for hundreds of thousands, even millions of years. The ecosystems down there, if they exist, evolved in total isolation, with no exposure to the outside world. And a single modern microbe of your drill, just one, could wipe out that ancient ecosystem before you get a chance to study it. You could destroy the discovery of the century in the very act of reaching for it. So even when you beat the blindness, the flowing ice and the vanishing lakes, you still have to do the final, hardest thing, which is to touch this pristine world without poisoning it. Any one of those 4 would make for a tough expedition. All 4 together make this one of the most difficult exploration challenges humans have ever attempted. And the fact that anybody has succeeded at all, that anyone has reached one of these lakes and pulled up living samples, is genuinely a triumph against a stacked deck. Which is exactly why the Vostok story is so important to understand in full, because it shows you both the triumph and the heartbreak of this kind of work. So let me tell it to you properly, because it's one of the great epics of modern exploration, even though most people have never heard of it. Lake Vostok, remember, is the giant one, sealed under roughly 4 kilometers of ice, believed to have been cut off from the outside world for at least 15 million years. An enormous body of liquid water, bigger than a lot of the lakes you could name off the top of your head, sitting in total darkness, untouched, for a span of time that dwarfs the entire history of our species. And the Russian team set out to reach it. Now, I want you to really grasp the scale of the commitment here, because it's almost unbelievable. They did not knock this out in a season. They did not do it in a few years. They spent decades. Decades. Field season after brutal field season, in one of the coldest, most hostile places on the planet, slowly grinding their drill down through that 4 kilometers of ancient flowing ice. Think about the human side of that. Researchers spending huge chunks of their careers, their lives, on a single hole in the ice. People who started on the project as young scientists and were near the end of their careers by the time it bore fruit. A relay race ran across generations, all aimed at one buried lake. And every problem we've discussed, they faced. The flowing ice tried to seal their shaft and bend their equipment. The depth was punishing, the cold was relentless. And looming over all of it was the contamination problem. The terror that after all those decades of work, they might foul the very water they were trying to reach. And finally, in 2012, after all of that, they made it. They drilled through the last of the ice and reached the water of Lake Vostok, a lake that had been sealed for 15 million years, and a team of human beings finally touched its surface. That is an astonishing achievement. Decades of effort, 4 kilometers of ice, 15 million years of isolation, finally breached. And here's the deflating, painfully human part. After all of that, the samples they got were inconclusive. Not a clean, ringing answer. Not a triumphant declaration of alien-like life thriving in the dark. Just murky, uncertain results, tangled up with exactly the contamination worries we keep coming back to. Because here's the cruel irony. The longer and more involved your drilling effort, the more chances there are for your own equipment and fluids to taint the samples, which makes it harder to be sure that whatever you find actually came from the lake and not from your own machinery. So after decades of heroic work, the answer came back as a frustrating maybe. We can't be sure. We can't cleanly say, which honestly is its own kind of lesson. It tells you that in this field, even reaching the impossible target isn't a guaranteed victory. The difficulty doesn't just stand between you and the water. It can rob you of a clean answer even after you've touched it. But, and this is so important, don't walk away thinking it's all murky disappointment, because the very next chapter of the story is a clean, ringing success. Because in 2013, just a year later, a different team drilled into a different lake, Lake Wilans, and this time the answer came back loud and clear. They reached the sealed water, and they found life. Living microbes, unmistakably alive, down in the dark, cut off from the sun. And not just barely alive, but a functioning ecosystem. Microbes feeding on iron and sulfur and nitrogen, pulling their energy out of chemical reactions, exactly as the whole chemosynthesis idea predicted. A complete working web of life, sealed away from sunlight, running purely on chemistry. That was the proof. That was the moment the dream became fact, not a theory, not a maybe, but a confirmed living world under the ice. And think about what those two stories tell you when you put them side by side. Vostok shows you how staggeringly hard this is, how even decades of effort to reach the most famous sealed lake on the planet can end in a murky, inconclusive shrug. And Wilans shows you that it absolutely can be done, that with the right approach you can reach into that sealed darkness and pull up living, breathing, iron-eating proof that life thrives where we thought nothing could. Together they tell you that this is real, this is possible, and this is brutally, brutally hard. Both things at once. Now let me pull on a thread we haven't fully explored yet, which is the question of just how alien this hidden life really is, and what it might mean for understanding life itself. Because here's something worth sitting with. The microbes in these lakes have been evolving in complete isolation for an incredibly long time. At Vostok, potentially 15 million years of being sealed off from everything else. Think about what that means. Evolution doesn't stop. Life keeps changing, keeps adapting, keeps drifting generation after generation. And if you take a population of living things and seal it away from the rest of the world for millions of years, with no new arrivals, no mixing, no contact with the outside, it will keep evolving down its own private path. It becomes its own little branch of life, shaped entirely by its strange, dark, sealed environment, drifting further and further from anything else on the planet. So whatever is down in those lakes isn't just life. It's potentially life that has been doing its own thing, in total isolation, for longer than humans have existed. It could be strange. It could have adaptations we've never seen. It could tell us things about how life copes with extreme cold, extreme pressure, total darkness, and a diet of pure chemistry that we couldn't learn anywhere else. Each sealed lake is like its own separate experiment that nature has been running, untouched, for ages, and we're only now starting to pick at the results. And every one of those experiments might have come out a little differently, depending on the lake's chemistry, its temperature, how long it's been sealed, what minerals are in its rock. A whole archipelago of isolated evolutionary experiments hidden under the ice, most of them never sampled. And this is why the contamination problem isn't just about not killing the locals. It's also about not muddying the experiment. If you drill in and accidentally drop your own surface microbes into that lake, you don't just risk wiping out the natives. You risk mixing your germs in so thoroughly that you can no longer tell what was originally there and what you brought with you. You corrupt the data. You ruin millions of years of pristine isolation in an instant, and you might never be able to cleanly figure out what the lake's life was actually like before you barged in. That's part of why the Vostok results were so frustrating, and part of why everyone is so obsessive about clean drilling. You only get one shot at a truly pristine sample from each of these lakes. Once you've touched it, it's touched forever. The seal that held for 15 million years is broken by you, and it never seals again. Let me put you inside that for a moment, because it's a heavy thing to carry. Picture this. You're the scientist whose drill is about to break through into a lake that has been sealed since before your species walked the earth. In the next few moments, you are going to be the first thing from the outside world to touch that water in 15 million years. That's an extraordinary, almost sacred kind of responsibility. Do it right, and you might discover a brand new branch of life. A window into how living things survive in the most extreme conditions. A rehearsal for finding life on other worlds. Do it wrong, let one careless germ slip through, and you might destroy or corrupt something irreplaceable. Something that took millions of years to become what it is and can never be restored. That's the knife edge these people work on. The discovery of a lifetime and the catastrophe of a lifetime are separated by something as small as a single bacterium on a drill bit. And that, again, is exactly why this is such perfect training for the search for life beyond Earth. Because if we ever do send a mission to melt down through the ice of Europa or Enceladus into their hidden oceans, we will face this identical knife edge, except even sharper. Imagine being the first to reach an alien ocean, and then realizing you might have seeded it with Earth bacteria, contaminating or destroying native alien life before anyone could even confirm it was there. That would be a tragedy beyond words. So the discipline we are building right now, here, drilling carefully into our own sealed lakes, learning to look without breaking, learning to sample without poisoning, is precisely the discipline we'd need out there. Every clean drill we perfect on Earth is a lesson we bank for the day we try this on another world. We are, in the most literal sense, learning how to safely look for aliens by practicing on the hidden life beneath our own eyes. Now let's step back and appreciate the sheer strangeness of the bigger picture, because I think it's easy to lose sight of how bizarre and wonderful all of this is. You live on the surface of a planet. You walk around on rock and soil, under an open sky, bathed in sunlight, surrounded by a food chain that all traces back to that sun. That's your world, and it feels like the whole story of life on Earth. But it isn't. Underneath the ice at the top and bottom of the planet, there's an entirely separate domain of life, running on completely different rules. No sun, no sky, no light at all, no photosynthesis. Just dark water, ancient ice, mineral-rich rock, and life that eats chemistry. It's almost like there are two biospheres on this one planet. The bright, warm, sun-powered one you live in, and the hidden, cold, dark, chemistry-powered one sealed beneath the ice, running quietly in parallel, mostly invisible to us, possibly for millions of years. And the kicker is that the hidden one might be the more important one for understanding the universe. Because the sun-powered surface biosphere, as far as we can tell, might be relatively rare in the cosmos. You need a planet at just the right distance from a suitable star, with the right atmosphere, the right everything, to get a warm, sunlit, photosynthesis-based world like ours. That's a fairly special set of conditions. But a dark, chemistry-powered biosphere under a layer of ice? That might be far more common out there. Frozen worlds with hidden oceans, kept liquid by internal heat, with chemistry happening between water and rock. Those might be all over the place, scattered around stars throughout the galaxy, tucked away as moons of giant planets. If life under ice, running on chemistry, is the more common form of life in the universe, then the hidden biosphere under our own eyes, the one we're only just learning to reach, might be the truest preview of what alien life actually looks like. Not little green men under a sun, but microbes in the dark, feeding on chemistry beneath a shell of ice. Which just goes to show how badly our intuition can mislead us about where to look for life and what it should look like. We grew up imagining alien life as creatures roaming alien landscapes under alien skies. Basically a remix of the sunlit surface world we know. But the real frontier might be the opposite of that. Dark, sealed, sunless, cold, chemical. The kind of place that, if you saw it from the outside, you'd write off as a dead, frozen rock without a second thought. The kind of place that looks exactly like the Arctic looks to you, when you picture that flat, white, empty expanse and assume there's nothing there. And we know, now, for a fact, that there is something there. We drilled down and found it living. So let me bring you all the way back to the surface again, to that image you started with, because I think it lands differently now. You're standing on the Arctic ice. Flat, white, endless, screaming wind, no landmarks. The deadest looking place you can imagine. Your gut says nothing's here. But now you know better. Now you know that under your boots, the ice itself is slowly flowing like cold honey, a frozen river creeping along on a clock too slow to see. You know that somewhere below, meltwater is pooling in basins in the rock, forming lakes that have never seen the sun. You know those lakes are connected by hidden rivers that sometimes surge and drain billions of liters in days, carving new paths in the dark. And you know that in at least one such lake, we drilled down and found a whole ecosystem of microbes, alive, feeding on iron and sulfur and nitrogen. An entire sealed world of life running on chemistry in a place the sun forgot millions of years ago. And you know something even bigger. You know that this hidden, dark, sealed, living world is a mirror of distant moons, hundreds of millions of kilometers away. Moons like Europa and Enceladus, with their own dark oceans under shells of ice. You know that by learning to reach our own hidden lakes, carefully, cleanly, without destroying what's down there, we are rehearsing the search for life beyond Earth. And you know that the whole effort is locked behind that maddening paradox, that we can't map this world because we can't reach it, and we can't reach it because we don't have a map. Which is why so much of it remains, even now, one of the last great unexplored frontiers, hiding in plain sight, right at the top of our own planet. All of that, under what looks like nothing, under what looks like the emptiest place on Earth. That's the part that I can't shake. The deadest looking landscape you can picture is hiding a living, moving, mysterious world, and we've only managed to peek into the tiniest sliver of it, with the vast majority still sealed in the dark, still flowing, still draining, still maybe alive, still waiting for someone clever and careful and patient enough to finally reach down and read the rest of the story written beneath the ice. Okay, so by now you're basically an expert on this hidden world, but I want to take you somewhere we've only touched lightly, because it's one of the most beautiful parts of the whole thing. I want to talk about the water itself, and how it moves, because the more you understand the plumbing of this buried world, the more it stops feeling like a collection of static lakes and starts feeling like a living, breathing circulatory system hidden under the ice. So here's the picture. You've got these subglacial lakes scattered around in the basins of the rock, deep under the ice. And your instinct is probably to imagine them as separate, isolated puddles, each one sitting quietly in its own little bowl, minding its own business. And for long stretches of time, that's not far off. They sit. They are calm. The water is still. Centuries roll by and nothing dramatic happens. But that calm is deceptive, because these lakes are not truly separate. They are connected. Underneath the ice, threading through the rock and along the base of the ice sheet, there are channels, rivers, hidden waterways linking one lake to the next, like a secret network of pipes running through the dark. And for a while, those channels can be quiet, barely flowing, the whole system in a kind of slow equilibrium. But the equilibrium doesn't hold forever. Pressure builds, water accumulates, a seal weakens, and then, without any warning that you could pick up from the surface, the system lets go. One lake suddenly starts draining, dumping its water through the channels, and that water goes rushing off toward another lake or away through the network entirely. And we are not talking about a gentle trickle. We are talking about billions of liters of water draining out in a matter of days. Days. An enormous body of water emptying itself through the dark in less than a week, surging through channels under kilometers of ice. And here's a part that I find genuinely beautiful and a little terrifying. As that water rushes through, it carves. Rushing water is one of the most powerful sculpting forces on the planet, and down there it's no different. The surging flood cuts new channels through the rock and along the underside of the ice. It reshapes the hidden plumbing. The map of where the water flows can literally rewrite itself in a week. So this isn't a fixed, static system that you can chart once and trust forever. It's dynamic. It's alive in the geological sense. The lakes fill and drain, the channels open and close and get recut, and the whole hidden water network is constantly, slowly, reshaping itself in the dark, completely invisible to anyone standing on that flat white surface above. And remember how we said scientists can detect these lakes partly by watching the surface of the ice rise and fall? This is where that comes full circle. Because when a lake down there drains away its billions of liters, the ice above it loses the support of all that water, and the surface can slowly sink down as the lake empties. And when a lake fills back up, the surface can rise. So from above, on the surface, you can sometimes see this incredibly subtle breathing motion, the ice gently rising and falling over months and years, as the hidden lakes far below fill and drain through their secret channels. The surface is, in a faint and blurry way, a readout of the heartbeat of the buried world. The flat white expanse you'd swear was completely motionless is actually, very slowly, breathing. And that, right there, is what makes this such a maddening target to study. Because think about it from the perspective of someone trying to reach one of these lakes. You spot a lake using your fuzzy detection methods. You start planning. But that lake is part of this dynamic, breathing, self-reshaping network. It might drain. It might fill. The channels might shift. By the time you've spent your years preparing your expedition, the system could have rearranged itself, and the lake you targeted could have drained away, leaving you to drill down toward the target that has simply gone. You're not aiming at a fixed object. You're aiming at one moving part of a moving system, and you have to hope it stays put long enough for you to reach it. It's like trying to schedule a meeting with a particular wave on the ocean. Now let's connect this back to the life question, because the dynamic nature of the water actually matters enormously for whether and how life survives down there. Think about it. If the lakes are connected and water sometimes flows between them, then the life in them isn't necessarily totally trapped in one little ball forever. When the water moves, it could carry microbes, nutrients, chemicals from one place to another. A draining lake could seed a downstream area with life. The whole hidden biosphere might be more connected, more dynamic, than you'd imagine if you pictured each lake as a sealed jar. And at the same time, the movement of water keeps things from going completely stagnant. It brings fresh chemistry, fresh minerals, fresh energy. For life that feeds on chemical reactions between water and rock, having water actually move and circulate, bringing it into contact with new rock and new minerals, could be exactly what keeps the whole system fed and alive over the long haul. So the same dynamism that makes these lakes a nightmare to study, the draining, the flowing, the constant reshaping, might be part of what makes them habitable in the first place. The movement that frustrates the scientists might be the very thing that feeds the life. There's a real poetry to that. The hidden world is hard to reach precisely because it's alive and moving, and it might be alive precisely because it's moving. The difficulty and the life are tangled up in the same restless flow of water through the dark. Now I want to zoom back out one more time and put the whole grand scale of this in front of you, because I think it's the thing to really hold on to. We have reached what? A tiny handful of these lakes? We drilled into Vostok after decades and got a frustrating maybe. We drilled into Wilans and got a clear, beautiful yes. Life feeding on iron and sulfur and nitrogen in the dark. And that's basically it for the headline successes. But there are many, many more of these hidden lakes, scattered across Antarctica and tucked under the Arctic ice, the vast majority of which have never been touched, never been sampled, never been seen by anything from the outside world. Each one a sealed bowl of dark water, each one possibly holding its own private ecosystem, each one the result of its own isolated experiment that nature has been running untouched for ages. Think about that catalog of unexplored worlds, not out in space, right here, under the ice on our own planet. Dozens upon dozens of hidden lakes, sealed in darkness, possibly teeming with life that has evolved completely on its own, with answers about the limits of life that we can barely guess at. And we've cracked open just a couple of them. The rest are still down there, still sealed, still in the dark, still flowing and draining and breathing, still maybe alive, all of them locked behind that same impossible paradox and that same tower of stacked problems. The blindness, the flowing ice, the draining targets, the contamination terror. And every single one of those lakes is a potential rehearsal for the search for life beyond Earth. Every clean drill into one of them is practice for the day we might try to melt down through the ice of Europa or Enceladus and into their hidden oceans. The frozen moons out there, with their dark seas under shells of ice, kept liquid by internal heat, with chemistry happening between their water and their rock, are mirrors of these lakes. So the more of these lakes we learn to reach, carefully, cleanly, without destroying what's inside, the better prepared we'll be to someday do the same thing on a moon, where getting it wrong could mean accidentally seeding an alien ocean with Earth life and destroying or corrupting native life before we ever confirm it exists. The discipline we built down here is the discipline we'll need out there. And that's the thread that ties this whole story together, the thing I want you to walk away holding. This hidden world under the ice is, at the same time, one of the last great unexplored frontiers on our own planet, and a practice arena for exploring other worlds. It's both the most local mystery imaginable, a few kilometers straight down beneath your feet, and the window onto the most cosmic question we have, whether we're alone in the universe. It's right here, and it's about everything out there, all at once. So let me bring it all the way home, back to where we started, because I think the image hits completely differently now that you know what's underneath it. Picture this one last time. You're standing on the Arctic ice. The wind is screaming across an endless flat white expanse. There are no landmarks, no trees, no hills. Just blankness stretching to the horizon in every direction. It is the most lifeless, frozen, empty-looking place you could possibly imagine. Every instinct in your body says nothing is here. This is a dead place. This is just ice on top of ice, on top of frozen nothing. And now you know how spectacularly wrong that instinct is. Because under your boots, the ice itself is slowly flowing. A frozen river creeping along on a clock so slow it looks frozen solid. Deeper down, at the boundary where ancient ice meets warm rock, under the crushing pressure of kilometers of ice and the steady heat leaking up from the earth, the ice is melting, and that meltwater is pooling into basins in the rock, forming lakes that have never once seen the sun. Lakes sealed in total darkness for hundreds of thousands, even millions of years. Lakes connected by hidden rivers that sometimes surge and drain billions of liters in days, carving new channels through the dark. The whole network breathing and reshaping itself beneath a surface that doesn't seem to move at all. And in that dark water, in at least one place we've actually checked, there is life. A complete functioning ecosystem of microbes, alive, feeding on iron and sulfur and nitrogen, pulling their energy from the chemistry of water meeting rock, thriving in a place the sun forgot before our species existed. Life with no use for sunlight at all. Life running on a completely different engine than everything you've ever known. An entire hidden biosphere, parallel to your own, sealed beneath the ice. Mostly invisible, possibly ancient, and we've only just begun to find it. And the truly staggering part is what that life means. It means life doesn't need the sun. It means life can take hold in darkness, under crushing ice, on nothing but the slow chemistry of stone and water. And the moment you accept that, the universe stops looking empty. Because out there, orbiting Jupiter, there's Europa, a frozen shell hiding a liquid ocean. Orbiting Saturn, there's Enceladus, spraying plumes of water into space from the sea beneath its ice. Frozen words we used to dismiss as dead rocks that suddenly look like exactly the kind of place where this hidden, sunless, chemistry-powered life could thrive. And by learning to reach our own hidden lakes, by drilling carefully into the dark beneath our own eyes, we are rehearsing right now for the day we go looking for life on those distant moons. Which just goes to show that the deepest mysteries aren't always the farthest away. We point our telescopes at distant stars and dream about alien worlds, and all the while one of the greatest unexplored frontiers, and maybe one of our best previews of what alien life actually looks like, is sitting a few kilometers straight down, beneath the most ordinary-looking frozen wasteland on our own planet. Hidden not by distance, but by ice. Locked behind a paradox that says we can't map it because we can't reach it, and can't reach it because we don't have a map. Defended by ice that flows like syrup and seals our shafts and bends our drills and walks off with our sensors. Guarded by lakes that drain away before we arrive. And protected, in a strange way, by the contamination problem itself, which forces us to approach this pristine world with a care and humility we rarely show anywhere else. And maybe that's the most fitting note to end on. Because there's something almost humbling about a frontier this close that we still can't conquer. We've sent machines across the solar system. We've mapped distant moons in detail. We've photographed the far side of our own moon. And yet a few kilometers below us, under the ice, there's a living, moving, mysterious world we can barely sketch in rough outline, that defeats our best technology, that keeps almost all of its secrets, that we've only managed to peek into through a couple of hard-won holes in the ice. It turns out the last great unexplored place might not be out among the stars at all. It might be right under your feet, at the very top and bottom of your own planet, sealed in the dark, flowing and draining and breathing and quietly alive, waiting for someone clever enough, careful enough, and patient enough to finally read the whole story written beneath the ice. So the next time you see a photo of that endless frozen white, that flat, blank, lifeless-looking expanse, I hope you don't see emptiness anymore. I hope you see a roof. A roof over a hidden world of dark rivers and sealed lakes, and ancient life that runs on chemistry instead of sunshine. A world we've only just started to touch. A world that's been there all along, right beneath us, longer than humanity itself, keeping its secrets in the cold and the dark, at the very top of the planet, just out of our reach.